Hello, this is a video about OAKProxy, a self-hosted, open-source, cloud identity-aware proxy. This video is not going to go in depth on the features and capabilities of OAKProxy itself, but today we're going to focus on the new domain join reference architecture. This will allow you to easily create a highly available deployment of OAKProxy that can join to your domain and proxy Windows integrated auth applications. I'm going to assume that you have a few of the prerequisites out of the way in this video, such as a network connection to Azure and an Azure AD tenant, and a few things like blob storage and key vault for deployment artifacts. But the rest of these common deployment steps we'll walk through. Okay, so here we are on an on-premise domain join client workstation. And I'm just going to show off a couple of the applications that we are going to expose to the internet today with our identity-aware proxy. This is a simple internal application representative of kind of legacy applications. It's built on IIS with ASP.NET Full Framework, and it's using Windows Integrated Auth to recognize who this user is. It also has an API that just returns some basic JSON, kind of the same information we see here, headers, username, but it's also using Kerberos and Windows Integrated Auth. And here is a second application that we're going to proxy, and it shows the same information, the incoming headers, the user, but it also calls the API, the first application, using constrained delegation. So it's passing the identity of the logged in user to a backend server, and we can see that the user's identity is flowing to the backend. Okay, one additional thing that I would like to point out is that these are internal applications. They're being resolved from our internal private DNS to internal servers. When we proxy these later, we'll see that we'll be using split DNS to create these names in the public DNS, and we will resolve these to our public service. The first thing we're going to do is get Azure AD ready and the OAKProxy configuration files. I'm going to use this commandlet new OAKProxy AD application. This is available in a PowerShell module in the Git repository that will eventually be in the PowerShell gallery. So here I'm creating two app registrations in Azure AD for the two applications that I showed. I'm just indicating that they have an API, and this is the app ID URI that's going to be used for that API, and that they also have a web page access mode, and here's the URL that will be used to access them. Now, I've used the same host name for this public access endpoint as we use internally. There's no requirement that you have to do that, but if you do, users will have a consistent experience from whether they're coming from inside the intranet or they're hitting the application from the internet. The URLs will be consistent. Okay, so I just created those two new applications, and I'm going to need to take these app IDs and put them in my configuration file. So this is my OAKProxy configuration file, and I just started from a template that is available in the documentation for the public-facing version of the reference architecture. Going through here, I've added the identity provider for my situation, Azure AD. Any OpenID Connect provider supported, and I've tested with Azure AD and ADFS. This claims provider will, by default, resolve users based on the on-premise SID claim that's coming through Azure AD, but if one is not available, such as the case of a B2B user or a cloud-only user, UPN matching will be attempted. This authenticator just says that based on that incoming claim about who the user is in the domain, we will transition to Kerberos authentication. And finally, here I have my two applications configured. They're configured in the same way. They just bind to the things we created above, the identity provider, the claim resolver, and the authenticator. So here is the internal URL, and it just so happens that our public-facing host name that will be entering the proxy via the application gateway is the same. Internally, the application is not using a secure connection, but the application gateway will require HTTPS, and it will actually terminate HTTPS and then just use HTTP within the corporate network. Down here, we're just configuring at the root level, we'll use OpenID Connect authentication, and at the /API level and everything below it will allow OAuth 2 token-based authentication. But for this particular application, we're also allowing the web session, so the OpenID Connect authentication, to be used on the API endpoints. You don't have to do this. This is an option. So I'm just going to go ahead and save those changes. And then I'm going to upload that to my artifact storage. Okay. Let's take one more step with Azure AD and admin consent those applications. They don't ask for many permissions, just sign in the user. But if we grant it now, it will create a more seamless experience for the user in the end. Now that Azure AD is ready to go, we're going to have to do a few things to prep our Active Directory domain. We're back here on a domain machine, and all I've done here is taken the snippets found in the reference architecture documentation and pasted them all into one script here in the ISE. I'm going to have to do a few things to clean this up. Each of these has a little segment of user entry and then some script after. So I'm going to do a quick replace for my domain. And then I can go ahead and run this. So that created a new OU and a new AD group for our VMs to land in. These are the VMs that will run OAKProxy, and they'll be automatically added. So that just created this account, XS OAKProxy managed, that will actually do the joining of VMs. We've gone ahead and created an ACL on the OU so that this account is only privileged to join computers and manipulate that group object within the OU. And finally, we're going to create the GMSA that actually runs the OAKProxy service. Before I do that, I actually need to change these target service principals. These are going to be the SPNs of the demo apps that we're proxying to. Okay. Let's just take a quick look at what we did. Here's our user that's going to be managing our new OU. And here's our new OU. And it has a group for containing the servers. We'll use this group to grant access to use the GMSA account. And if we take a look at this, we can see the ACL we created here. This is going to allow it to manipulate that group object and join computers. Okay, so now that Active Directory is set up, Azure AD is set up, and our OAKProxy configuration file is uploaded, we just need to look at my parameterization of the reference architecture template. I've already gone ahead and filled it out. I've stored all of my secrets in Key Vault, so they're not actually in this parameterization file. I've got the username and password for the VMs that will get created in the VM scale set, the domain we're going to join, the OU we're going to put the VMs in, which we just created, the group name we're going to put the VMs in, which we just created, and the GMSA that's going to run the service, and the user that is going to actually join these machines to this OU. All of this we just created. I've set up availability zones here, so we'll be spread across 3 availability zones within a region. This is just specifying where the virtual network, the pre-existing virtual network with corporate access and domain access is already, and the subnet within that VNet we're going to drop the VM scale set. The subnet we're going to drop the app gateway in. Here I'm specifying that this is public access mode because this template has 2 modes, public and private. One where we create an app gateway and we present a new public service to the internet, and a private mode where we only deploy load balancers and just present OAKProxy within the private network. I've already gone ahead and acquired a publicly trusted certificate for all of the host names that we're going to be presented to the internet. This uses subject alternative names for each host name. You could also use a wildcard certificate. This is the password to decrypt that certificate. Finally, we've got the DNS label for the application gateway. This will just be the prefix of the fully qualified domain name of the application gateway. And we're going to need that as kind of the final step to point our new domains at the app gateway. These are the versions of the VM DSC configuration and OAKProxy that we're actually going to install in the VMs. I have defaults in the template, but you should always specify this. And I also default this to GitHub, but for anything other than a toy deployment, there should be your own storage here. Now, for your deployment to be highly available, this storage must also be equally available. So if you're deploying zonally, then you'll have to actually have zone redundant storage here, because this will be a dependency on your production deployment. And finally, the URL to the configuration file that we set up earlier. All we can do now is start this off. And this will take a while, so I'll use the magic of editing to fast forward. Okay, so that took about 12 minutes. What we need to do now is point our public-facing DNS toward the newly deployed application gateway. So I'm going to take a look at the outputs from the template, and we see the new FQDN of our application gateway. I'm going to point both host names of my test applications at this new FQDN with CNAME record. And I'm using Azure DNS here. If we come back here to our domain machine, nothing's really changed. We're still resolving our applications from the internal DNS. And we're still accessing them directly on the corporate network using Kerberos. Before I jump over and test what we deployed, I'm just going to come back into Azure AD for a second and do something. I've already gone ahead and assigned a user on a modern workplace device to our first demo app, and I'm going to go ahead and do that to our second one as well. Okay. Okay, so now I'm here on a nice new modern workplace device. I'm signed in as an Azure AD user. The machine is Azure AD joined. It has no VPN. It has no access to the corporate network. I've never been to the new demo app on this computer, so we're going to see what the very first time experience is like. There you go. I got the same nice single sign-on experience that I did on the domain with the AD user, but now I'm signed in with Azure AD, and the experience is exactly the same. But the application, nothing has changed. So the application is still receiving negotiate authentication, so Kerberos data right here, and it has no idea that I'm a user coming from the internet. And this just shows that even through OAKProxy, we can do triple hop constrained delegation. So I'm using constrained delegation to go from OAKProxy to imitate this user to the front end or middleware application, and then it's calling the back end and flowing that Kerberos identity. On this machine, if we look up our apps, you can actually see that they are being resolved to a public internet address, and that's the full domain name of our Azure Application Gateway. You see both applications actually pointing to the same app gateway, which are routing to the same OAKProxy cluster, and it's directing to the different backend applications based on the incoming hostname. If we come back here to my computer, we can also test out B2B. I'm already signed in with Azure AD to this computer and to Edge with Azure AD. I'm B2B'd over to the tenant we've been testing in, and in that tenant I've also, my B2B user has been synced down to the ADDS domain so that there's a domain shadow identity that represents me. And because I am a member of that tenant, I get the same great single sign-on experience. So here's the experience if we're coming in with no single sign-on. We'll immediately be redirected to Azure AD to sign in. That's it. So very quickly before I destroy this deployment, here's what our entire deployment looks like. It's got a zone redundant application gateway. a standard SKU public IP, which is automatically zone redundant. We have zone redundant storage for storing our key material. And we have a zone redundant VM scale set. Every VM is just using ephemeral disks. And here are our VM instances. Now that we've seen public mode, I've rolled back that deployment and we're going to try private mode. This is useful for highly regulated environments where all the traffic needs to remain internal, or you don't want to use Azure Application Gateway but your own app delivery controllers or your own security stack. You can point that stack at this private deployment. So all I've changed here for the deployment line is I'm using my private parameters. And the private parameters are pretty much the same as they were before, except I've removed the application gateway parameters and I've changed to private access mode. The certificate data is exactly the same. However, it works a little bit differently in private mode. Rather than installing to an application gateway, since we don't have one, we'll have layer 3 load balancers. The certificate is actually installed on the VMs themselves. Now, you don't actually have to provide this in private mode, but if you don't, it's your responsibility to get a certificate installed on the VMs. And you could do this through an auto-enrollment policy with AD certificate services and a auto-enrollment GPO assigned to the OAKProxy OU. Just a couple things need to change here. So OAKProxy has to actually listen on HTTPS itself, since it's going to be terminating those connections through the load balancer. I had to change the destination names for the service to an internal name because those host names we were using before are now pointing to the load balancer. And finally, I just need to tell OAKProxy where to get its certificate. Okay, so we'll go ahead and just kick this deployment off. Okay, our private mode deployment is complete. And now I'm going to need to look at my deployment outputs. This is the IP of this internal load balancer that I've deployed, and I'm going to need this IP to update my internal DNS records. Okay, because this private mode deployment is all internal, I can't use the Modern Workplace device. I have to come back to this machine that's on the internal network. I've gone ahead and updated both of the applications to point to the internal load balancer IP address. And I've also gone ahead and assigned the application to this user so that it will show up in their panel. There we go. Same kind of experience, but this time we are logging on with Azure AD only. Now we are on the corporate network and we could go straight to the backend application with Kerberos, but what you could start to do in this scenario now is actually segment off that part of the network and require access to the application to come through this OAKProxy cluster. So this is what that private mode deployment looks like. It's pretty similar to public mode, except that our application gateway has been replaced by 2 load balancers. And these load balancers are standard SKUs so that we get zone redundancy. There's an internal and external load balancer. This is just the way standard load balancers work. Once you've hooked up to a standard internal load balancer, you will need a separate one to have egress traffic to the internet. And the only reason there's egress traffic to the internet here is to connect to Azure AD and Azure services. This public IP does not create any ingress to this machine. There's no public ingress to this machine because there's no inbound rules on this external load balancer. That's it. Thanks for watching.